Okay, so automatic calibration of the constitutive driver. The way I've set this up is using MATLAB function fmin search, which is just finding the minimum of a function without using its derivatives. And you can see more information on the actual MATLAB page. The main way this is set up is, as usual, using all the functions that Matteo made. The only difference is it loads the material CSV file, and this provides you a list of parameters with their associated values. You define which one of these parameters you want to calibrate. Technically, you could calibrate all of them at once, but since it's not a very smart automatic calibration, it's better to do one or two at a time, relevant to the test that you're comparing them against. So this just gets the file, this calculates the number of iteration using the calibrate function. What the calibration function does is simply you define the stress path from the experimental. In this case, I had this function which contained, or this data which contained K0 isometric, linear isometric, epsilon or strains during UCS, stresses during UCS, PQ during isometer. Well, a few tests, and using the fine stress path from experimental, you just, well, here is pretty much done manually because I was first setting stuff up, but you define for each stress path the I code and number of steps, the same as done for the normal constitutive driver. The main difference is that, for example, you get the stresses from the experimental. So, for example, dx at 400 kPa, you do first stress at a certain value and then strain according to the experimental data. Doesn't matter, it's just defining the stress path for the calibration, which will always stay the same, and then just runs the constitutive driver itself, loads the result of the constitutive driver, and then this is a bit of a faff because it's all repeated multiple times. What it does is for each for each test, it will try to fit the variable you inputted, minimizing the difference between, well, the results and the driver, and the result of the driver and the experimental result. For example, here, if is the result of the function I'm trying to minimize, this specific one I'm just doing with the UCS, and as you can see here, instead of you can do, for example, trapezoidal integration of the area, of the difference of the area of the experimental numerical data, or you can do divided by the trapezoidal integration of the, or numerical integration of the value itself. What I'm doing here is just, I have the peak value, I have the peak value from the, I have the peak experimental value 3K, I have the peak numerical value, which I get from the results, and then I just minimize their difference, and that's all there is to it. But instead of, the main difference is that instead of just trying to fit them by changing the width of the yield envelope, it's changing the inclination of the critical state line. And this just does the same, or the way I set up the function is does the same for each different test, and does the mean of all the different tests, which can work, but then I just do this with the, in the end, I'm just doing this with the difference of the UCS because I'm just kind of comparing to calibrate against this parameter after all the other parameters have been calibrated. And it just returns the minimum, and the function just cycles trying to minimize it. So if I just run it, it will take a while.
Are you recording yourself?
Yes, I am recording myself.
Okay. Let you finish that.
Well, stop here.